Hello, I'm Dr. Abdurrahman Qawasmi. Today we will discuss our first lecture about signal analysis and processing. As you know, the concepts of signals and systems arise in a wide variety of fields, and the ideas and techniques associated with these concepts play an important role in almost all branches of electrical engineering and in many other engineering and scientific fields as well. Therefore, systems and signal processing represent a body of knowledge that is of essential concern to the scientists and engineers. The signal can be defined as a function of one or more independent variables, and it can contain information about the behavior or nature of some phenomenon. As an example of the signals, we have a continuous time signal, which can be defined as a function of time t, which has a real value over the time. In figure 1, we see uh, an example of a continuous time signal. As you see that the amplitude of this signal is varying according to the time t. On the other hand, there is a discrete time signal, which can be defined as a function of an argument that takes values from a discrete set x of n, where n is one of real numbers from minus infinity to plus infinity. As you see, there is a big difference between a discrete time signal and continuous time signal. In a continuous, as we said before, you can find any instant time value of the signal x of t. But on discrete time signal, you can find only values over a discrete set of time. The discrete signals can be obtained by taking samples of an analog signal at discrete instants of time. The values for x may be real or complex. The square brackets are used to denote a discrete time signal, x of n, to distinguish between the continuous time and the discrete time signal. Figure 2, as you see, represents a discrete time signals for a discrete time instance of time. As you see, x of n contains different values from minus 3 to plus 6. Systems. What is a system? A system is transformation from one signal called input to another signal called output. So, if you have an input to the system, you will have an output which is different from the input. So, the system that we call it makes something like change to the input to produce the output. We have two major categories of systems, continuous time systems and discrete time systems, as shown in figure 3. Of course, we will in the future discuss in details the difference between continuous time and discrete time systems, and we will show examples and how to implement such systems. We have an example for a continuous time system. Y of t equals x of t plus x of t minus 1, and y of t equals x squared of t. As you see, in continuous time system, the output is y of t, the input is x of t, and in continuous time systems, the variable is the time In discrete time systems, we have also y of n equals x of n plus x n minus 1 and y of n equals x square of n. As you see, it is similar to continuous time systems, but instead of time t, we have n, which is also instant time, but as a discrete values. In some systems, we can have multiple inputs and multiple outputs, and in this case, the system is referred to as a multiple input, multiple output MIMO system as shown in figure